Okay, we'll try the light like this. Okay, so the integral is sine squared times cosine cubed. And believe it or not, this is a substitution problem. So we know that sine and cosine are derivatives of each other, so maybe that helps it to make sense. So if we were to say make u equal to sine of x, then du would be cosine x dx, right? So we could substitute here then, and that would get rid of the two sines that we have and one of the cosines, but we'd still have a pair of cosines left to deal with, right? Cosine squared x, and then one of these cosines together with the dx, so this makes du. Do you see? So u squared times cosine squared x dx. So the question is, how can we get rid of this cosine squared when we've decided to make u equal to the sine of x? And here's where you call upon some of your trigonometry. You remember this. Man, if you were in my class, I told you that this is one of the most important things that you do in trig. It comes up all the time. And look, it's coming up here. Look, we can write this relationship as cosine squared is equal to 1 minus the square of the sine. And so if we replace cosine with this, sine has been replaced by u. So we can replace this with 1 minus u squared. Pretty clever, huh? So this will be u squared, and then this is, again, 1 minus u squared du. And now all we need to do is multiply this out. We get u squared minus u to the fourth du, and that's pretty easy to integrate using the power rule. So 1/3 of u cubed minus 1/5 of u to the fifth plus maybe a constant. And the last thing to do is to go back and replace the u's with sines, and so our final answer is 1/3 times the cube of the sine minus 1/5 sine of x taken to the fifth. You can do what I've done here anytime one of the powers is odd. What you do is save one of the cosines to use as the derivative and use the Pythagorean relationship between sine and cosine to convert all of the others. It's kind of fun.